Okay, today we're going to demonstrate this iPhone 7 that comes without Wi-Fi. And first of all, we would scan through the prompt. Yeah, as you can see, the Wi-Fi cannot be activated, and also the Bluetooth as well. Okay, now we will start to disassemble all the components first, and then left the motherboard only, and we'll have to examine the motherboard next. First, we take off the battery and all the screws and connectors like display, camera, and also the antenna and the duct flex. Basically, just remove everything. Just left only the motherboard. The screw has to be categorized, otherwise when you mix up it's really hard to reassemble them again. So try to categorize the screws. Now these two antenna is very fragile. Remove them carefully with the tweezers. Okay, and in the video that we forgot about the SIM card holder, so it took a little extra time for us to find out that the SIM card holder is still intact. Once removed, the motherboard can be taken off easily. Okay, and now we examine the motherboard under the microscope. This is the Wi-Fi chips, and for the Wi-Fi problem, it's pretty straightforward. That we will simply just remove this old Wi-Fi chip and then replace it with a new one. And if it's worked, then the problem is solved. First, we will scrape out the underfill that surrounds the Wi-Fi chip. The heat temperature is 260 and the airflow is 40. And when doing this, we use the small muzzle, will be okay. And when removing all this underfill, you try to be as careful as you can, and also try to clean them very well. Okay, now we are about to remove the Wi-Fi chip. This we use this blade and also the heat gun, the big muzzle. Okay. Once removed, we will clean the motherboard first. Exchange the higher melting point 10 to the lower melting point 10 using the soldering iron. Next, we will use the solder wick to take away the extra tin. Normally we would apply some more flux, but in this case the flux is enough. So, and then clean up the motherboard. As we examine through the the motherboard, we found that there's a missing pad. So next we will be dealing with the missing pad, try to recover it. We will do the lollipop that basically reconnects the line from the circuit from the motherboard and then to the pad. The pads itself is in rectangular shape, but we can do a lollipop will be fine, because all we need that is this lollipop can replace the pad, so that when we're soldering back the chip, the function still works. Okay, first we scrape out the motherboard to see the lines, the circuit coming from the motherboard, and then we will apply some tin first. It'll be easier for us to reconnect the circuit, and we'll be able to make a pad with the circuit. The wire that we're using is from camera. Okay, the camera wire is really thin, so when we try to reconnect the circuit, we have to be more careful, and this is how we do the pad. Okay, using two blades and coordinate with each other. And for the circuit, we use the UV Max to hold this pad in place. UV Max has to apply some heat in order to make it solid. And after that, we would scrape up the pad. To do this is because when we're soldering back the chip, this pad has to hold the soldering ball. Otherwise, if it's not connected, then there will be a function that is missing. Okay, this is, we are applying some tin to the wire, micro jumping wire, so it would be easier for the soldering ball to reconnect. And then we would rebuild the Wi-Fi chip. This is a new Wi-Fi chip. We use this iPhone7 stencil to rebuild the Wi-Fi. And also, before rebuilding the Wi-Fi, you have to clean the Wi-Fi first. When doing the rebuilding, the stencil, each hole on the stencil tries to be in the center of each pad, so you will get a more equivalent quantity of the soldering paste on each hole. The soldering paste, we choose medium melting point ones, which is 183 degree. When doing the reballing, we have to use the tweezer on our right hand to press the stencil against the chip. And this step is called the reset. We would apply some heat and the flux to make each soldering ball in shape. So now we're about to put back the soldering back the Wi-Fi IC. When soldering back the Wi-Fi IC, we had to use the big muzzle as well. And the temperature is around 340 and airflow is 40. We try to keep the motherboard as clean as always. And for replacing the Wi-Fi, since it's PCIe system that this hard drive NAND has to be take down and unbound the Wi-Fi. So next we'll be taking off this NAND on this iPhone 7. As usual, if there's any underfill that surrounds the chip, we have to scrape out the underfill first. And as always, the temperature is around 260 and the airflow is 40. A small muzzle will be okay when doing this. And these all small resistors, capacitors are really tiny, and it's very important to the NAND, so try not to remove them with the underfill. Sometimes we use the number 11 blade to help us to clean underfill. That's it's very narrow between the small components and the NAND itself. So when finished scraping off the underfill on each side, we're going to take down the NAND. For taking down the NAND, the air temperature is 340 and the airflow is 40, and we will be using the medium muzzle. In this case, it's actually very successful because there's no pads missing and everything is very clean. And as always, when we're trying to clean the motherboard, we have to exchange tin first from higher temperature to lower temperature, and then we would take off the extra tin using the soldering wick. Since there are still extra underfills, we will use this number 16 blade with a heat gun that's 260 and 40 to scrape out the extra underfill under the NAND. And then we have to clean the NAND as well. Exchange tin first. Next step is very important. We're about to unbound the NAND with the Wi-Fi. We use this special machine that can help us unbound. Simply just press an unbound button on the right corner. Okay, when we push in the NAND, the machine will read the information on the NAND, and then we push the button to unbound it, and then take it off. And we can now rebolting this NAND back to the motherboard. The pads on the NAND is very big, so it's relatively easy for rebolting. But the stencil is a little bit different. The stencil is thicker than the normal, because we will try to make a bigger soldering ball than before. Like always, we use the tweezer to help us to press the stencil against the chip. And the temperature is 340 and airflow is 40. I think the middle muzzle will be okay. Okay. Every time we remove the stencil, we have to do the reset again on the chip to make the soldering board in shape. Okay, now we're going to resoldering back this NAND. There's a positioning points on the left bottom corner. That's where you can compare this point with the layout. And we apply the heat 340, airflow 40, wait until it's melt. We did this little push to make sure that the tin is melt, so that it will push back itself, push back the IC by itself. So it means that the soldering board is in place. Okay, now we're going to put everything back to check if it's working. When we reassemble the components, we try to put back the connectors first, and on the very last step would be the battery. Okay, you see this Apple logo. The machine is booting on. And we will quickly examine the Wi-Fi function and the Bluetooth function. Okay, now we're able to activate the Wi-Fi, and their signal seems okay. And there you go. I think the problem of the Wi-Fi has been solved. So that's for the Wi-Fi replacing demonstration. Thank you.